Okay, we're going to look at the derivative of log functions. I really should scratch that title because it's when we're dealing with differentiating logs, it's normally to do with natural logs. So what we're really going to look at is the derivative of the natural log of x. And in the formula booklet, it tells you what it is. If y equals the natural log of x, then dy by dx equals 1 over x. That's the derivative function, 1 divided by x. If you don't believe me, here it is. Okay, the natural log of x, if that's the function, the derivative is 1 over x. Now, I'm just going to do a short proof as to why that is. Okay, I'm going to prove to you why the derivative of this is actually this. It's a little bit easy. It's quite easy to do, actually. Remember from the last clip that if y equals e to the x, then the derivative of y is still e to the x. Okay, so just remember that. Keep that in mind. Okay, we'll use that in a second. All right, let's begin. All right, if y equals the natural log of x, then e to the power of y equals x. Remember, that's just the law of logs. Okay, remember the logs tell you what power do you need to raise e to get x. The answer is y. So if you raise e to that power number y, you should get x. But what I'm going to do is I'm going to differentiate. I'm going to differentiate this function like this, dx by dy. So think about what I'm doing here. I'm going to differentiate x with respect to y. So what would that be? Well, if it's e to the power y, it would just be e to the power y. Okay? And then alright, well what we really ideally want is dy by dx. Okay? So then what would dy by dx be? Well, if we've just worked out what dx by dy is e to the power y, then dy by dx, flipping a fraction almost, but it's technically not doing that, would be 1 over e to the power y. Okay? But then we obviously want everything in terms of x, but then what is e to the power y? Well, e to the power y, we declared earlier, e to the power y is x. So we end up with 1 over x. There you go. That's the proof. dy by dx of the natural log of x is 1 over x. Okay, but anyway, we're going to do some rules that you need to remember. Okay? Alright, so number 1. If you had a number times the natural log of x, okay, let's just prove using the chain rule what the derivative of that is and see if we can come up with the general rule. Okay? So let y equal the natural log bit. Okay, so y equals ln(x), then y would, so let u equal natural log of x, then y would equal 5u. Okay, so dy by du would equal just 5, and du by dx would equal 1 over x. And therefore dy by dx using the chain rule would just be 5 times that. 5 times 1 over x. So it's 5 over x. And the general rule is if there's a number multiplying the natural log, then dy by dx is just k over x. Okay, k times 1 over x. Okay, that's one thing to remember, right? This. A number times natural log just becomes k over x. But here's a really important one that you need to remember, okay? I want you to try and find a rule for the following examples that we do. Say y equals natural log of 6x. Inside now, 6x. Okay? I'm going to use the chain rule. I'm going to do it a little bit differently. I'm going to let u equal this bit inside. So y equals natural log of u. And then u would equal the 6x. So dy by du would equal 1 over u. And du by dx would just equal 6. And then to find out dy by dx, we just multiply them. So do 6 times 1 over u, which equals 6 over u. But we've got to replace the u back with whatever it is, which is 6x. So that equals 6 over 6x. Well, you can see the 6's cancel out, so we're left with 1 over x. Okay, so the differential of this, dy by dx, equals 1 over x. Okay, right, we'll do a few more, and then maybe you can see a rule coming out of this. Okay, next one. We're on number 3. I think we are. Alright. Natural log of 1 plus 6x. So again, I'm going to let u equal this bit inside. So u equals 1 plus 6x. And then y would equal the natural log of just u, as in natural log of u. Dy by dx equals, dy by du would equal 1 over u. Du by dx would equal just 6, and then we can multiply them to get dy by dx, which is 6 times 1 over u, which is 6 over u. We've got to replace the u back with this, so it'll be 6 over 1 plus 6x. Okay, unfortunately nothing cancels out here, so we're left with this. Right, but notice we end up with whatever's inside the bracket seems to go underneath, and then what we're left with on top is the derivative of whatever's in the bracket. Okay, so there's a little thing you should look at. Right, let's do another one. We're on fourth one, IV. Okay, y equals natural log of x squared plus 6x cubed. Okay, it's horrible, but I'm going to let u equal this bit here, so u would equal x. Okay, we have to use a chain rule, by the way, because it's a composite function. Plus 6x cubed. Y would again be log of u, so I'll just write dy by dr. dy by du equals 1 over u again. Du by dx equals 2x plus 18x squared. We have to multiply them, so dy by dx equals 2x squared plus 18x, no hang on, 2x plus 18x squared, and then we're going to times it by 1 over u, so we'll just put it over u, and again this would be 2x plus 18x squared over u, which is this x squared plus 6x cubed. And again, what have we ended up with? We've ended up with whatever's in the bracket going to the bottom, and then on the top we've ended up with the numerators. It's like the 1 over x business, but the derivative goes to the top and the rest of it goes underneath. Okay, so let's look at doing it quickly then. So example v, y equals natural log of x to the power 5 minus 8x cubed. Okay, now, so let's figure out quickly. First of all, it's going to be a fraction, like all the others were. Remember, this is the same template as, the log of u, and letting u equal x to the power 5 take away x cubed. This is exactly the same as this, really. It's a template to follow. If it looks like a composite function like this, follow this template. Right, well, what happened? Well, this thing ended up on the bottom, and then the derivative of it ended up on the top. Well, what's the derivative? There will be 5x to the power 4 minus 3 times 4 is 24x squared. There you go. And that's the derivative function. So remember this little trick. If it looks like this, then the derivative dy by dx equals the derivative of u on top divided by u like this. Okay, so remember that. Okay, little trick. That's not in your formula booklet, but remember that. Can we stop it there and look at some more examples in a moment?